Welcome to the fourth and last video in the series on properties, states, and add-on processes. So let me just briefly talk about what we've covered in the past three videos and what we're going to do in the current video first. So in the first video in this module, we talked about object states, properties, and the difference between the two. We also introduced semio processes and explained how the objects in the standard library are all made of different processes, and we specifically talked about how we can use add-on process triggers and state assignments to enhance or extend the logic for different components of our model. So specifically, we achieved these objectives through extending the subway model that we have developed and verified in related modules. We implemented type-based processing time for our cold and toasted sandwiches using a model entity state variable and add-on processes. That's what we did in the second video in the module. In the third video in the module, we talked about how we can change the symbol of entities by changing the value of the model entity.picture state variable, which is a state variable associated with our model entity object. We also implemented the bulking logic for our customers using add-on processes. In this video, we're going to learn how we can do conditional routing using a model entity state. Now I would like to make a couple of notes here. First of all, we started this module with a complete model of the Subway restaurant that we had developed in previous modules. So if you would like to learn more about the model development and the verification process, you can go back and refer to the related modules where we cover these topics. Also, we have a whole module dedicated to different types of routing logic, and in fact we cover conditional routing in more depth in that module. So if you would like to learn more about conditional routing or other types of routing, you can refer to that module. However, in this video we're just interested to see how we can use a model entity state variable to do conditional routing and how we can implement this in Simio. So I think with this brief introduction, we're ready to go ahead and start talking about our system here. So the system that we're going to consider here again is a typical Subway restaurant where we have 5 stations, where in the first station customers order the type of bread and meat and cheese that they want in their sandwich. And then the sandwich will go to the oven to be toasted. And then the sandwich and the customer will go to the veggies station where they put lettuce, tomatoes, and other types of veggies on their sandwich. And finally, they go to the cashier and make the payment. And after that, customers go to the drink machine and get the drink, and then they leave the system. So, as for the data for this problem, the arrival rate is 32 customers per hour, and service times are all triangularly distributed with the parameters that you can see here. So I'm not going to go over the parameters here because we have talked about this model before. And 70% of the customers want their sandwich toasted and 30% will get cold sandwiches. However, the current policy requires that we maintain FIFO throughout the system. In other words, customers that get cold sandwiches still need to wait in the queue at the oven station for those customers that are waiting for their sandwich to be toasted. So passing is not allowed in the current operating policy. So bulking is basically when you go to a restaurant and you see that there is a long line and you decide to go somewhere else. So basically in this model we're going to assume that customers bulk if there are 6 people in the system. As for the performance measures, We would like to evaluate the performance of the system during lunch rush, so we would like to do a steady state analysis. And specifically, we're interested in server utilizations, average time in system for all customers, and expected number in system. However, we're also interested in the percentage of customers that bulk and the average time in system per customer type. In other words, customers that get cold sandwiches and customers that want their sandwich toasted. So here is the model that we left off with in the third video. So let me just briefly go ahead and recap what we did in the second and third videos. So in the second video, we used a model entity state variable that we named proc time on oven, processing time on the oven, to model this idea of type-dependent processing time for our cold and toasted sandwiches on the oven. So if I select my model entity and go to its definitions and states, you will see that we have defined this real state variable, proc time on oven, that has a default value of 0 for our model entity. And then for our oven station, for the expression for the processing time, we use our model entity.proctime on oven state variable, which stores the processing time for the corresponding entity on the oven. And we sample the processing time for each entity right here at the output node of the source. And as you can see, I have an add-on process here. So whenever an entity enters the output node of the source, these are the steps that I perform. So first, with a probability of 0.3, I have a cold customer, so my processing time on the oven will be 0. Otherwise, with a probability of 0.7, my processing time will be sampled from the triangular distribution. And then I also changed the symbol for my cold customers. So let me go back to the model, select my model entity, and as you can see, I have my first symbol in my symbol list as red, my second one, which is for the cold sandwiches, as blue, and then the third one is for the bulkers that I will talk about shortly. So by default, model entity.picture is 0. So when I increment it here, it becomes 1, and I'm essentially selecting the second symbol in my symbol list, which is the cold, or which is the blue color for my cold sandwiches. And then regardless of the type of the sandwich, so I'm doing the rest of the steps for all of my entities, both cold and toasted sandwiches. And here I check the number in system, number of customers in the system, and if I have 6 customers in my system, the customer that has just arrived will bulk. So if this condition is true, I set the destination node for my arriving entity to input at bulk, which is the sink that I have used to destroy the bulkers. Otherwise, the destination node for the entity is input at the first station, which is bread meat station. Finally, the last thing that we added to the model in the third video was we used state assignments on our bulk sink to change the color of the customers that bulk. You will see that for under the state assignments properties on entering, I have a state assignment that essentially changes model entity.picture to the third index in my list, which is the black color right here. So if I actually set a breakpoint here and run the model, you will see that at some point when I have 6 customers in my system and a new customer arrives, the new customer will bulk. So here is the case. So I have 1, 2, 3, 4, 5, 6 total customers in my system, and this toasted sandwich has arrived. And if I actually step, you will see that the customer bulks, and also its color changes to black. So now that we have implemented the bulking logic, let's go ahead and estimate the two performance measures. So we're specifically interested in the percentage of customers that bulk and average time in system, but this time per customer type, per hot and cold customers. So I would like to talk about the second metric real quick first. So I need to go back to my model, and I would like to show you the results of an interactive run that I have performed for 300 hours. And what I'm interested in is the time in system, and I'm interested in the average time in system in minutes. And as you can see, I can get the information about time in system from three objects in my model. So I can get the time in system for all customers, which is 6.5436 minutes. Time in system for those customers that entered the bulk sync, which is 0, of course. They bulk in 0 simulation time. And time in system for those customers that exit through the exit sync, which is 7.2529. And the reason this value is greater than this value is that in the first one that we get from the customer object, we basically include the bulkers, so we have some 0 values when we calculate the average time in system here. So that's why we see a smaller value than the one we get from the exit sync object. But as you can see, I don't get any information about time in system per customer type because I haven't implemented the logic to collect that statistic yet. So since I can get time in system from the sync object, what I would like to do, I would like to remove this exit sync and instead add 2 new syncs to my model. So I'm going to have 1 sync and 2 syncs here. So I'm going to call the first one cold sync and the second one hot sync. So I want cold customers to exit through my cold sync and hot customers to exit through the hot sync, so that I can get separate time and system statistics for each customer type. Now this time, of course, again, we can go ahead and define an add-on process that implements this logic of this routing logic that we are interested in. Alternatively, we can also use the link weight to make this decision, this routing decision. So this time I would like to show you guys this alternative approach. So now I'm going to click on my new connector here, and I would like to use a condition here for my selection weight. So I'm going to use ModelEntity dot, and I know for cold customers the processing time on the oven, which is the state variable that I have defined, is 0. So now what Simio does is that whenever an entity is going to be routed out of the output node of the drink machine, if this condition is true, if the processing time on oven for that model entity is 0, then that entity will go to the cold sync. And I'm going to need to implement the alternative condition on the other sync. So this one will simply be equal, or the expression will be ModelEntity dot processing time, this time a value that is non-zero. So now when I run my model, let me go ahead and set breakpoints here so I can verify that this is actually working. I can run my model, and whenever an entity leaves the system, I would like to verify that cold entities exit through the cold sync, hot entities exit through the hot sync. So this one is a cold customer that exits through the cold sync. The next customer is a hot customer, and it exits through the hot sync. And I keep running my model to verify that it's actually working. So I'm going to let you guys try this for a while, for a number of entities, just to make sure that everything is working correctly. So the last thing that we're going to do is perform an experiment with this model. So this time, instead of going to the project home and create a new experiment, I will just basically duplicate the previous experiment that I performed with the earlier version of this model, just to save some time so that I don't have to set the run configurations. And I would like to rename this one to model with add-on processes, but this time with bulking. So now I'm going to have to add my responses that I need for my performance measures. So basically I need 3 responses. The first one is my percentage.bulk, so bulk percentage. And the expression for it will be the number of customers that bulk divided by the total number of customers that were created. So the number of customers that bulk, I can get that from the bulk sync. So I can go to my bulk sync and then input buffer number entered. And I would like to divide this value by the total number of entities that were created. So I can get that value from my source object. So I can go to my enter source object. Then it's output buffer, and then number entered. So now this gives me the proportion of customers that bulk, and if I actually multiply the whole thing by 100, I will get the percentage of bulkers. So I'm going to say OK. So that's my first performance metric. The second one is the time and system for cold customers. So I'm going to call it cold TIS. Cold TIS. And I know I can get this value from my cold sync. So I'm going to go to cold sync, time and system average. And the last response that I need is time and system for hot customers. So hot TIS, and I can get this from my hot sync object. Again, time and system and average. So now I'm going to run my experiment, and since I copied my experiment, everything is set up. So I'm just going to click on run and wait until the model is run. So now my experiment is run, and you can see that almost 10% of my customers bulked, and for my cold customers I am getting 0.117 hours for time and system, and for hot customers I'm getting 0.122 hours. And of course, if you want to get these values in minutes, you can simply multiply the expression that you have for the 2 responses by 60. And of course, if you compare the results of this model with bulking with the earlier version of the model that did not implement bulking, you will see that your overall time and system for all customers, your overall number and system, and the utilizations have all decreased compared to the model that did not have bulking. And of course, that's because now you fewer people enter your system, so you expect that to happen. So this is kind of to again verify that your results make sense and actually are in line with your expectations.